Today's video is going to go over the observer pattern. This pattern has a lot to do with thinking about how state of one object may have an effect or may need to notify different other parts in the application or different other objects. A good example is thinking about an activity log that might need to interact with multiple parts of a UI. So if some activity gets added to some log, it needs to update a notification panel, it needs to update a user feed, it needs to update a dashboard widget. So think about how we can make sure that if one change is happening in state on the log, how can we ensure that this is also propagating or creating the state change and letting all the other pieces of this application are notified as well. First thing we want to think about is how do we kind of implement this without the observer pattern? So going back to the idea that we have this activity log and all of these different parts of the application or the UI. We have the notification panel, the user feed, dashboard widget, and we might want to add on more and more and more things that every time the log's state has been changed, like we have a method called log_state. For each of these individual parts of this application, we're going to have something to refresh it or make sure that we're changing the state or we're changing something within that. So on the notification panel, if we updated the log, we want to say, hey, since we updated the log, we want to go first, update the notification panel. Then we want to add some information to the user feed. Then we want to add some information to the dashboard widget. The only problem is that now that we think about this, every time the log has been changed or something has been added or removed, now we're having too much tightly coupled, hard-coded relationships between each of these objects. So they become much more hard-coded with one another. If we want to add more connections or more dashboard widgets, or we want to add more components to our application that are tied to the log, then we end up hard-coding those portions into our original log that's setting those states. This becomes increasingly more difficult, it becomes too tightly coupled, so it ends up not becoming a dynamic list of objects. We're not able to really subscribe or unsubscribe in runtime, and ends up being something that has to be more hard-coded beforehand. If we look at the observer pattern, this is how we can remove this coupling and we can eliminate this complicated relationship that we might have between one part of the application that's connecting to all these other portions that need to notify anytime something has happened. The pattern overview, so the Gang of Four says it defines a one-to-many dependency between objects so that when one object changes states, all its dependents are notified and updated automatically. It's called a behavioral pattern because at runtime, it will have this one-to-many broadcasting to any number of observers. The subject broadcasts, each observer decides what to do. It only knows they implement a single method. If we think about the subject programs to the observer interface, so there's no coupling to any of the concrete types. Each of them are independent. They can do exactly what they want to do. All they know is that they've been broadcasted some state change that has happened. Here's the structured diagram. We have 4 participants. There's 2 interfaces and 2 concrete classes. First, we have the observer interface. The observer interface declares just one method, and that's the update method. The subject interface declares 3. It has add, remove, and notify. Together, these 2 interfaces are in the entire contract. Neither side references the other concrete type. Here in our demo application, we have log, which implements subject. So here it holds the state. there's a log list and subscriber list. This is the observer list. When the state changes via this method setState, it calls the notify, which iterates through the observer list and calls an update to each. The user implements the observer. It holds a reference to the log it watches. When the update is fired, the user reaches back to the log via getState to pull the latest entry and renders it. Let's look at the observer interface first. This is just the simple update method. One method. It has no parameters. The subject doesn't pass data on notification. It just signals that something has changed. The observer then pulls whatever data it needs from the subject directly. This is a classic pull method or pull model. It pushes the signal, it pulls the data. Why are there no parameters? Because different observers may want different slices of the subject state. Passing data in the update would mean the subject has to know what data every observer needs, defeating the purpose of decoupling. The pull model keeps observers in control of what they assume. Here is the subject interface. We have these two methods, add and remove, that manage the subscription list at runtime. Observers can join and leave without the subject needing to be rebuilt. It's not something that we have to hard code or prepare ahead of time. We can do this while the application is running. Notify broadcasts to everyone currently in the list. So the parameter type is observer. It's the interface, not the concrete class. This is the key. So the log knows about the observer. It doesn't really know about the user. Here we have the log. This is the concrete implementation of the subject. It holds two arrays. It's the observer list of the current subscribers and the log list of the log entries. SetState is the action trigger. It appends a new entry and then immediately broadcasts it. Log notify, it loops through the observer list and calls update on each one. That's it. The log doesn't import the user. It doesn't call any user-specific methods. It doesn't know what the update will do. So this creates a total decoupling from its own subscribers. And here we finally have the user. This is the concrete observer. It takes the log reference in its constructor, and this is how it knows where to pull the state from when it's notified. When the update fires, the user calls this log getState, and that's the pull step. It takes the last entry from the slice, log list slice, and it appends it to its own DOM list. Each user instance has its own DOM target, so all three render independently even though they received the identical notification. Here we have the observer and subject interfaces. If we look at both the interfaces together, they kind of show a little bit more of the pattern. If we look at the subject, it references the observer, and that's the only cross-reference. Observer has no knowledge of the subjects at all. This asymmetry is intentional. The observers are passive recipients. The subjects are the ones managing the list and broadcasting. The entire pattern builds on these two contracts. Here we have the code of the log. Here's the full class. Beyond the pattern's core methods, log also has this set time and get time. For the demo, there's like a timestamp feature. This is just particular to the application. The observer mechanics are entirely in the observers list. Here we have the notify and setState. Calling the notify. The filter in the remove is just a one-liner so that we can call this in case we need to have any unsubscription for anyone on the observer list. And here we have the code for the user. This is the full user class. The constructor takes a log by reference. This is what makes the pull model work. When update fires, the user will go back into log, get its state to get the full log array, and then it'll grab the less entry. So this means that the query selector with the class selector built from the user can kind of render the state that has the last state that it has from the log. This is kind of a wonky demo, but the idea is that each user instance targets its own panel without any hard-coded IDs. This way, it's able to kind of create this fake rendering that we're trying to demonstrate within the DOM. If we look at the index TypeScript file, this is where all the wiring happens. We have 6 lines that write the 3 observers to 1 subject. Adding a 4th user is just adding another user and just adding the log.add, so we can continuously add more users. The log class doesn't change. There's nothing extra that we have to add. This is kind of how we can extend the pattern. For our observer UI demo, we have a activity log subscription. If we look up here, we have 3 different users. Those are our observer. They subscribe to the log. Log is considered the subject. And then the log will perform the notify, which on each user that is subscribed will perform the update. Let's look at the index TypeScript. This is how the application is all tied together. We have first the log and the user. The log is what we consider the concrete subject. The subject is what we have for the add, remove, and notify. Add and remove means that we have this list of observers that are subscribed to the log. What we do then is for each of these users, we add the log to the user. That means that each user is able to get the log state. We can pull in the state. This is what we mean by the log list. This is what is being kept, the latest log entry. For here, it's this database, fake database that's being generated each and every time. And here we are setting the time here, which means that we will also push in here, and through here we'll also have the update for the state as well. Adding the log to each of the users as well means we are adding to this observer list. So we're doing both. We're connecting the users to the log, meaning that we connect the subjects to the observer to the subject and vice versa. That way the subject can update the observers and observers can be notified of any changes that are happening with the subject. So looking more carefully, if we have a click on any of these user, they will call this update log function. And from here, all it does is we're going to set the state to the unique log. So it will mutate to this entry of recent time and user log. So when we click it here, it adds it to the log. When we click it here, it adds the time to the user. And we do it here, and all of the users will be notified of this change. If we look specifically at the set state, when there is a set state, first we will push the log list to that log state, That's the one that we had here from the Typescript unique log that we're creating. And from here, we'll also call the notify. The notify is actually going to go through each one of these observers, and we'll call the update. And for this, on the update, this will get the state. It will get the log list that's being generated by the state, or the log list. And from here, it will also make sure to add it to that specific user log. This way, we're able to create a separation here, able to log the time across the board, make sure that we can update all of the users. If we also add another user, all it required would be to just, again, create a new user here, add the log to it, and here we can generate the user by the string. So we could do user4 and just add the log, and that would all that we would have to do here. We would decouple a lot of the implementation, and these two would technically not be integrated together, hard coded together, meaning we could make any changes here, make any changes here, mostly because we are coding to the interface, meaning we're calling the notify here. And from the notify, we're only creating the update here. And the update is what's going to be implemented in the subjects here. And so in that case, if we wanted to add other subjects to the observer instead of user, we would also be able to, or other observers to the subject, we would also be able to do that without having to create any more implementation. All we have to do is just remember to create this update, because that's the only thing that's being called on within the subject here. Server is the right choice when multiple components need to react to the same state change, especially when the subscriber set isn't fixed at compile time. It means specifically that we want to have a system or application that's more dynamic. So considering that we have subscribers that we may add, and we want to make sure that they're all updated, this is a good pattern to consider. We can use it for reactive UI updates, event systems, login pipelines, and any publish subscribe scenario. It's a pattern behind virtually every modern front-end framework, so React state propagation, the Angular RxJS observables, views, reactivity system, all observer variations are observers at their core. Here we look at when not to use. We have to consider the trade-offs. So we don't want to use the observer when the notification order matters and you need to guarantee it. The order observers fire depending on the order that they were added. We are just adding the observers to this array. When we do that, we're just calling it in this for loop, so we don't have a specific order that we are calling them. We just call them once they're added in that specific order. So we have to be cautious, because also observers have side effects that build on each other. There can be cascading notification chains, which can be hard to debug. Also, there's this issue that can happen with memory leaks. If observers are never removed, they just stay in the list indefinitely, and this can prevent garbage collection. And there can be high frequency state changes across many observers. If we do that, then you can flood the call stack without debouncing. Here are some real world analogies. The first one is thinking about a newsletter. So you subscribe to a blog. When the post goes up, every subscriber gets an email. The blog is the subject. Each subscriber is the observer. The blog doesn't know your name. It just sends to a list. You can unsubscribe anytime, thinking about like the remove function. The second analogy is a stock ticker. A stock price updates. We think of a broker app or portfolio tracker or price alert. They're all subscribed to that ticker, which can fire simultaneously. There's one change, many reactions. There's no coupling between any of the reactions themselves. The third example is the DOM event listener. When you click on a button, the browser broadcasts a click event to every register handler. The button element is the subject. Each add event listener is a callback, is an observer. Remove event listener is the remove function. This is an observer at the platform level. It is baked into every browser in the world. Patterns that are easy to confuse with observer. The first one is the mediator. It also handles decoupled communication, but it's a many-to-many through a central hub. All parties route their messages through the mediator object. So this is the mediator object. It coordinates. The observer is a one-to-many broadcast. The subject notifies the observers directly. The mediator itself reduces coupling between multiple peers. The observer reduces coupling between one broadcaster and many listeners. If we think about the pub-sub model, the event emitter, this one takes the observer one step further. There's publishers and subscribers, and they do not reference each other at all. They communicate through an event like an event broker, like nodes, event emitter, or a message queue. In observer, the subject holds the direct reference to all of these observers. But in a pub sub, neither side knows the other exists. So pub sub is more decoupled, but adds an intermediary and is harder to trace. In summary, there are three things to remember. First, the observer defines a one-to-many broadcast through two minimal interfaces. There's a subject that has those methods add, remove, and notify, and then there's the observer that only has the update. Second, the subject notifies and the observer pulls. This is what keeps the subject ignorant of what the observers actually do with the data. And third, in this repo, the log is the concrete subject, the user is a concrete observers, and subscribing the 3 users to one log, it only takes 3 lines. If this helped anyway, just subscribe. I'm going to be covering all the other Gang of 4 patterns in this series, each with a live TypeScript browser demo. The source is in the GitHub repo in the description, so you can run it yourself. Next, I'm going to go over the state pattern, where an object will change its behavior based on its internal state object. Observer and the state pattern pair naturally for these reactive state machines, so it's a great next watch. All right, I'll see you there.